Okay, our lesson today is to be able to read and identify scatter plots, identify correlations between data, and write and interpret an equation of a line of fit. Our essential question today is how do scatter plots and lines of fit describe relationships between data? Our first definition today is a scatter plot. It is a graph that relates two sets of data by plotting the data as ordered pairs. The scatter plot to the right shows the amounts X in grams of sugar and the numbers Y of calories in 10 smoothies. In this first example, the scatter plot shows the amount of X in grams of sugar and the number of Y calories in 10 smoothies. Our first question is, how many calories are in a smoothie that contains 56 grams of sugar? Well, the first thing we want to do is to locate 56 grams of sugar on our graph, and we see that sugar is on the x-axis, and we locate 56 grams of sugar, which would be right in between 54 and 58. We see where that point is on the y-axis, and we see that at 56 grams of sugar, we're at 270 calories. So for answer A, we'd have 270 calories. For question B, they ask, how many grams of sugar are in the smoothie that contains 320 calories? Well, our calories are located along the y-axis, so we have to find 320 calories on the y-axis, and that's here. We go across the y-axis, right, to a point, and we see that it's this point right here. We go down to the x-axis, and we see that 320 calories means that there's 70 grams of sugar. So 70 grams of sugar at 320 calories. Question C asks, what tends to happen to the number of calories as the number of grams of sugar increases? Well, we can see that as we look at the data from left to right, the number of grams of sugar, when they increase, the calories increase as well. So we're looking at something that looks along this line here. As grams of sugar increases, so do the calories. All right, so we have our correlations here. In this first graph, we see a very strong negative correlation. We see that as x increases, y decreases, right? As we move along the x-axis, your y values decrease. So this would be a strong negative correlation. That's strong, and that's negative. What makes it strong is the fact that the points are tightly collected along a general line that goes from left to right. Whereas when we look at the second example, we see that the values still tend to go down from left to right, but they're not so strongly centered around the line, right? There's a lot more space around that line. So this would still be a negative correlation, just not as strong, right? And it's not as strong because the points are not as close to a line that goes down from left to right. This example here would be an example of no correlation, and it's no correlation because you can't see generally if the points rise from left to right or if they fall from left to right. We see that the points are just scattered all throughout the x and y axis, so there is no correlation or relationship there. In the next example, we see our first positive correlation. What makes it positive is that the points generally rise from left to right. As we move along the x-axis, right, as x values increase, so do the y values, right? As x increases, so do the y, and that's what makes for a positive correlation. And if we look at our last graph, this would be a stronger positive correlation because the points are more centered around the line, right? See how we have this space here, right? We don't have as much space, between the line and the point. So this would be a strong positive. correlation. Okay. We continue down here, and you're asked to describe the correlation between the data in each scatter plot. Right? We see in example A that the points are just scattered along the x-axis and the y-axis. And if we look above, right, that would be an example of no correlation. Right? So this would be no correlation. And if we look at example B, we can see that generally the points decrease as x increases. Right? As the x values increase, as we move right along the x-axis, your y values decrease. So this would be a negative correlation. You don't have to identify it as a strong negative because, yeah, it's kind of hard to tell. There is some space, but they are generally along the line. So just identifying it as a negative correlation, that's going to be fine. In example 3, you're asked to identify the correlation you'd expect to see between each pair of data sets and to explain. Right? So in example A, it says that the number of pets a person owns versus the number of books a person has to read, or a person has read last year. Well, when you think about it, the more pets that you have, the less time for reading you would have. So there would probably be a negative correlation, right? Because more pets, as your x values increases, the amount of time that you have to read, or the number of books that you read, that would decrease. So this would be a negative correlation. And that's because as one thing increases, another decreases. In example B, we have ticket sales and the number of people in the audience. All right? The more tickets you sell, which would be your x values, the number of people in the audience, would also increase. So as sales increase, the number of people increase, so that would be a positive correlation. And then finally, example C, of runner's time and the distance to the finish line. Well, as a runner's time increases, the distance to the finish line is going to decrease. So this would be an example of a negative correlation. All right. Next page. Now we want to be able to draw lines of fit. Lines of best fit, you use technology, but we're going to just draw lines of fit in our classroom. When we have a line of fit, we call it a trend line. It's a line that approximates the relationship between the variables or data sets of the scatter plot. Some key ideas or the steps involved. Step 1, we will make a scatter plot of the data. In our first few examples, that scatter plot is done for us. Next step 2, we want to decide whether the data can be modeled by a line. In each one of the examples we do, the answer will be yes. Step 3, draw a line that appears to fit the data closely. There should be about as many points above and below the line. And for step 4, we want to write an equation using 2 points on the line. The points do not have to represent actual data pairs, but they must lie on the line of fit. Okay, here's our first example. We're told to refer to the information in the table about the cost of cookies. We are to construct a scatter plot using the data, then draw and assess a line that seems to best represent the data. Well, the data has already been plotted for us, and the line has already been drawn for us. So we want to be able to we want to be able to use the line of fit to make a conjecture about the cost of cookies in 2013. Well, the year since 2013 is going to fall right about here in between 2012 and 2014. So we want to know, right, this value here. And year 13, it looks like that's going to be $3. Get that a little crooked. Let's fix that. If I can, fix that line. There we go. Right, and it looks like at year 13, it's going to be $3.50. 35 cents because it's right in between 3.3 and 3.4, so that'll be 3.35. So when we're asked to use the line of best fit to make a conjecture about the cost of the cookies in 2013, looks like the cost of the cookies is going to be $3.35. So we can use our line of fit to make conjectures or reasonable assumptions based on the line that represents the data we're looking at. Okay, here we want to be looking at the length of a baby alligator over time. So now we're going to have to plot the data points ourselves, right? So we want to look at that and say, okay, at month 0, right? So that's when you're first born. Month 0, he's at 22 inches. Month number 1, we're at 22.5. That's going to be right in here between 22 and 23. Month 2, right? We're getting our data from here. Month 2, we're at 23.5. So month 2, 23.5 is going to be here. Month 3, we're at 25. So we plot that point. Month 4, we're at 26. Plot that point. Month 5, we're at 27.5. Plot that point. Month 6, we're at 28.5. Where's that? That's going to be here. Month 7, we're at 29.5. 29.5 is going to be here. So now we want to draw our line of fit. And you do your best to approximate points. All right, you do your best. And let's see, we want to come down here. All right, we do our best with that. All right, and we try to get something like, let's see, same number of points above and below the line. Yeah, let's see, something like that. There's no perfect science involved here, but you see we have 3 points above the line, and 1, 2, 3, 4 points below, so or 5 points below. So I'm going to fix that a little bit. Now I have 3 above, 2 below. All right, there's no perfect way to do this. All right, but you're going to try your best. And maybe, let's see, we get something like this. How's that? That's 1, 2 above, 1, 2 below. Maybe a little bit more. Not that one. All right. Let's see. Yeah. 1, 2, 2, something like that, right? There's no perfect way to do it. You gotta just do your best. And now we have to pick 2 points on the line. That could be a little tougher. Right, so let's see what we got. This is a good point here, right? We know the exact x value is 7, the exact y value is 29.5. So we'll do that, 7, 29.5. And then we have what? Here's another good point here, right? That's it, 3, 25. All right, so those are the 2 points we're going to use. Now, when you do this on your own, your 2 points are going to be different because when I did this problem in the notes, I had 2 different points. But when you draw your lines of fit, that's going to happen. 30 people in a class, you might have 30 different lines of fit. So for this example, this is what we come up with, and we're going to have to roll with that. So we graph the data, we've drawn our lines. So part A and part B are done. Now we go about writing the equation. And when we write the equation for a line of fit, the first thing we need is the slope. So we're going to start with M is equal to 29.5 minus 25, and that's going to be over 7 minus 3. 29.5 minus 25, what's that, 4.5? Yes, and 7 minus 3 is 4. So we have 4.5 over 4, so we can write that as 45 over 40. 45, right, over 40. And if I simplify that as a fraction, 45 over 40 divided by 5, that's going to be what? 9 times 5 is 45, 9/8. Right? I like to write my slopes as fractions in simplest form. So now we need our b. To find our b, we use y equals mx plus b. And we choose one of these 2 points. I'm going to use the 3 and 25 just to avoid using the decimal. So that's going to give me 25. Right? I replace, remember, that's an x value, that's a y value. So my x value is going to be replaced with 3. My y value is going to be replaced with 25. So we have 25 is equal to 9/8 times x, and my x value is going to be 3 plus b. So now I have 25 is equal to 9 times 3 is 27 over 8 plus b. And what's 27 over 8? 3 times 8. 8 times 3 is 24. So what's that? 25 is equal to, what's that? 27 over 8. 3 and 3/8. 3/8 is 0.375. So that's 3.375. I did that right. Plus b. Let me just double check that. 27 divided by 8, clear. 27 divided by 8, yes, 3.375, good. And then when we solve for b, might as well do that here. No, not that button. I want to use my calculator button. So when I use my calculator button, I'm going to do 25 minus 3.375. I'm going to get 21.625. Oops. I get 21.625 is going to be equal to b. Now that's different than the equation, like I said, that I did when I came up with the notes, but everybody's equation is going to be a little bit different, right? But the slope should be similar, and the y-intercept should be similar, right? So I wind up with y is equal to 9 over 8 times x plus 21.625. Now I'm just going to show you what my equation looked like, right, for the notes, because it's a little bit different. So when I did this problem, to prepare my notes, which one is that? That is this problem here, I think, right? No, this problem here with the alligator. So was my slope 9/8. Here my slope was 7/6. Right? 7/6 is 1.16. 9/8 is 1.125. So they're close. Here my y-intercept was 21.25, and for the notes, right, or the example that we're working on now, a little different. My y-intercept was, let's see, here my y-intercept was, right, 21.625. So once again, the equations are close, and that's, the best you're going to do, because we're not a computer, right? We're human beings. Right? And then it says, use the equation to predict the baby alligator's length next September. Well, September is 12 months, and our x values are the months. So to predict the length, it would be y is equal to 9/8 times 12 for the 12 months, plus the 21.625. Right? And, using a calculator is appropriate here, because it just is. So I'm going to do 9 times 12 divided by 8 plus 21.625. Right? That's going to be 9 times 12, clear. 9 times 12, that's equals, divided by 8, equals, plus 21.65, equals, and I get 35.125. So I get 35.125 inches for the length of the alligator in 12 months. And let me go back and see what I got when I did the notes. So I got 35.125 here, and when I did this with the notes, I got, let's see, 35.125, 35.5. So once again, real close, right? And that's what's going to happen when you're doing lines of best fit, right? You're going to, all the answers should be close, but they're, very unlikely to be exactly the same. Okay, let's take a look at our next example. The scatter plots show the number of cellular service subscribers in the U.S. Write an equation in slope-intercept form for the line of best fit. I'll interpret your slopes. All right. So when I look at this line here, I want to find 2 points where I know the exact x and the exact y. And it looks like this would be a good point here, which would be 9 and 275. Right, that point looks like it's right on the line. And I want to find another point right on the line, and it looks like this point here is good. Right, it looks like that point is right on the line, and that's 3 and 150. So we're going to use those 2 points to write our equation. Start by finding our slope. 275 minus 150 over 9 minus 3. That's going to be 125 over 6. I'm going to leave my slope as a fraction, but if you want to write it as a mixed number, it's okay. That's what? 41 and 2/3. Right? But I'm going to use my slope as the fraction when I do my equation. So now we have to use y equals mx plus b to find our y-intercept. I can use either one of these 2 points. I'm going to use this first point here just because the numbers are smaller. So remember this is an x value, it's a y value. So I'm going to use 150 for y. My m was 125 over 6. My x is going to be 3. I'm going to add b. Right, I'm going to do 125 times 3 divided by 6. Right, 125 times 3 divided by 6. 125 times 3 equals, divided by 6 equals. And then I'm going to subtract the 62.5 from 150. Right, like that. So it's going to be 62.5 plus b equals 150. And then when we subtract, we wind up with what? Subtract 62.5, subtract 62.5, we wind up with 87.5 is our b. So now we have our equation. Y equals 125 over 6 times x plus 87.5. There's our equation. Now, we were asked to, with my highlighter, we were asked to interpret the slope and y-intercept. Let's do that with a highlighter. It's just going to look cooler. So, I'll get my highlighter. Right, we were asked to interpret the slope and the y-intercept. So let's do that. Right, let's understand, make some sense of what this is. So our slope, our m, is 125 over 6. Now what does that mean in the context of this problem? Well, remember, 125 is our change in y. So those are millions of subscribers. So we have 125 million subscribers, and our denominator are the change in x. So those are the number of years. Because it's increasing, our m means that we have 125 million subscriber increase every 6 years. Million subscriber increase, every 6 years. Every 6 years. Right, so that's what our slope means in the context of this problem. What does our b mean? Well, our b is 41 and 2/3. Right, so the b, in the context of this problem, which is our y-intercept, which is 41 and 2/3, I'm sorry, not 41 and 2/3. Our b is 87.5. What does that 87.5 mean in the context of this problem? When data collection began, there were 87.5 million subscribers when data collection began. All right, next example. We have another scatter plot. We're asked to do the same thing. All right. So, for this scatter plot, we want to look along the line and look for 2 points. Right? I want to look for 2 points that are on my line. And it looks like this is a good point here, which is 7 and 70. Right, that looks like a good point. And then I have, let's see, I want to look along the line. This looks like a good point here. And that's 4 and 65. Right, so you want to pick 2 points that are on your line, right? And notice that it doesn't necessarily have to be one of the, points that were, the data collection, right? But 2 points on the line. So part C, write the equation. We start with our slope. M equals 70 minus 65 over 7 minus 4. That's going to be 5 over 3, right? So 5/3 is our slope. We have to find our b. So we use y equals mx plus b. Y I'm going to replace with, we'll do 65 and we'll do the 65 and 4. So this is 65 is equal to 5/3 times 4 plus b. So we get 65 is going to be equal to 20 over 3 plus b. All right, so 65 equals, what's 20 over 3? 6 times 3 is 18. So that's what, 18 2/3 plus b. We subtract the 18 2/3. Subtract 18 2/3. They cancel. All right, and when we subtract 65 and 18 2/3, it gives us 46. And 1/3 is equal to our b. So our equation is y is equal to 5/3 x, right? Our slope plus the 46 1/3. We want to know the graduation rate in 2020. So 2020, years since 1998. Well, 220, the year 2020 would be 22 years from 1988. So x is going to have to be 22. So y is equal to 5/3 times 22 plus the 46 1/3. So y is going to be equal to, when we do that, all that in the calculator, we wind up with 83%. And if we were asked to interpret, right, once again, fancy highlighter, right, we're asked to interpret the slope and y-intercept. In the context of this problem, what's our slope? Well, our slope is 5/3. Well, what does that mean in the context of this problem? Well, remember, numerator is the change in y. That's the graduation rate as a percentage. The denominator is the years. So every 3 years, we have an increase of 5%. Right? Every 3 years, there is a 5% increase. There is a 5% increase in graduation rates. In the graduation rate. Graduation rate. Alright, and then our y-intercept. Y-intercept is 46 1/3, and it means that the graduation rate was 46 1/3 when data collection began. The graduation rate was 46 1/3% when data collection began. That's not very good. When data collection began. Alright. Next problem. So we have our bat. Right. It says you're asked to predict the number of bats that will be living in an abandoned mine after 3 years. To start, you find the number of bats that have been living in the mine during the past 8 years. So we're given the data in the table. Part A, graph the data. Part B, draw the line of best fit. Oh no. It looks like my microphone came out, so I hope. Right, looks like my microphone came out. I'm not sure how long it was out, but I'm not going to redo it. Just plug it back in. Sorry about that. So let's get going here. So let's start by plotting the data. So we want to plot 0 and 327. So 0 and 327, that's a little less than 330. We have 1 and 306. It's going to be about here. Oh no, that's 1 and 310. That's a bad spot. Right, 306 is going to be here. We have 2 and 299 about here. 3 and 270. 4 and 254 is about here. 5 and 232 out there. 6 and 215 about here. 7 and 197 about here. All right, we draw our line. All right, and you're trying to get an equal number of points, above and below the line. All right, so probably gonna get something like that. And let's see. All right, something like that looks good. Now let's move that over a little bit. Yeah, okay. So, what points am I going to use? Let's see. I have, let's see, what do we have that we could use? I like this 1 and 310, and this 11 and 130. So we have 1 and 310. We have this 11 and 130. All right, so we'll use those 2 points. So we finish part A and part B. Right, we have to write part C. We want to write our equation, and once again, when we write our equation, we start with the slope. So m is going to be equal to, we have 130 minus 310. Right, that is over 11 minus 1, which is going to be equal to negative 180 over 10, which is equal to negative 18 for our m. Then we use y equals mx plus b. We're going to use, I'll use this first point here, so I'm going to replace x with 1 and y with 310. Right, so that's going to give us 310. It's going to be equal to our slope, negative 18, times x, which is 1, plus b. So this is 310 equals negative 18 plus b, and 18 divided by 328 equals b. When we write our equation, y equals negative 18 times x plus, we have 328. So that's our part C, the equation of the line. Part D, how many bats in 3 years? Well, in 3 years, that would be year 14, right? Because we're at year 11, so 3 more years would be year 14. So y equals negative 18 times 14 plus 328. Oops, let's clean that up a bit. Plus 328, 28. So y equals negative 252 plus 328. Y equals 76 bats in 3 years. 76 bats in 3 years. In 3 years. All right, that's part D. All right, that is answer D. All right, last one we're going to do. And I don't know if we get through all these in the lesson, but hey, right, you guys get to watch it in the video lesson, I guess. I'm going to zoom out a little bit so I can see the whole screen. All right, let's zoom out. There we go. All right. What are we told? The table shows the number of people who have attended a festival over an 8-year period. Make a scatter plot of the data and draw a line of fit. Write an equation of the line of fit, and then interpret the slope and y-intercept of the line of fit. Predict the number of people who will attend the festival in 10 years. So we start with our graph, putting our points in our pairs. First one we have is 1 and 420. Okay, so I find 1 and 420. It's going to be, I don't know, a little bit more than 400. We have 2 and 500. 2 and, so that's 600. There's 500 there. 3 and 650. 600, 700, so 650 is going to be about there. Then we have 4 and 900. That's 4, that's 1,000, so 900 is going to be here. We have 5 and 1100. So that's 1,000 here, so 1,100 is going to be here. We have 6 and 1,500. Well, this is 6 and 1,400. 1,500 is going to be there. 7 and 1,750. 16, 18, 1,750. And then we have 8 and 2,400. 8 and 2,400 is going to be, wow, all the way up there. So we almost have a curve, and like it's really increasing pretty quickly. But the data does generally rise from left to right. Now we're looking for 2 points on the line. So let's see what we got here. I don't know. I'm adjusting my line to see if I can make it work. Let's see. 7. I like that line. Alright, and then I'm going to use 2 points on that line. So I'm going to use the 2 and 600, right? Because that point's right on the line. And then I got this point right on the line, right? But you could use any point on the line, but those 2 points look pretty good. So I have 2 and 600. It's going to be 1 point I use. And then my other point is 7.5 and 1,800, comma 1,800. I'll use those 2 points. And then we go one step at a time. We start by finding m. M equals 1,800 minus 600. Right? 1,800 600 over 7.5 minus 2, which is going to be equal to 218.2. 218.2. Then we use y equals mx plus b. Choose one of the 2 points. Which point am I going to use? I'll use the 2 and 600. So that's going to be 600 equals 218.2 times my x value, which is 2, plus b, divided by 600 is equal to, what's that, 200, 400, 36.4, 36.4 plus b, and we get b is 163.6. 163.6 is equal to our b. Then, let's interpret the slope and y-intercept. The slope is 218.2. That means that attendance increases by 218.2 each year. Attendance increases by 218.2 each year. And my B of 163.2 means there were 163.6 people in attendance year 0. Year 0 attendance. That is my 163.6. So, once we have our M, we have our B. My equation reads y equals 218.2 times x plus 163.6. There's my equation. Alright, and are we asked to do anything else? Use the equation to predict the number of people who will be in attendance in festival year 10. So, year 10, if I look at my graph year 10, right, that's always cool to do. Like, see how accurate that's going to be. If I use my graph year 10, looks like it's going to be about 24, maybe about 2,500-ish, or 20, let's say, something like that. 24, that's 2,000, that's 2,400. Let's see what my equation says. So we have y equals, right, my year 10, right, year 10, so that's going to be y equals 218.2 times 10 plus the 163.6 times 10, so y equals 2,182 plus 163.6, so 18, 20, yeah, so y equals, I get 2,345, 2,345.6 people. All right, so there's our lesson. You have a lot of examples of slope-intercept form and using a scatter plot and data to write the line of best fit. I hope that's been helpful.